name is Madison, and this week we're going to be looking at an application of the cross product. So the question is, find the area of the triangle whose vertices are 1, 1, 5, 3, 4, 3, and 1, 5, 7. The first thing we need to do is find some vectors. So we're going to start with the vector PQ. And we find this by subtracting the components. So 3 minus 1 is 2, 4 minus 1 is 3, and 3 minus 5 is negative 2. We do the same thing to find PR, and we get 0, 4, 2. Now we take a cross product. So we have I hat, J hat, K hat on the top. Then we put in our vectors 2, 3, negative 2, and 0, 4, 2. So now we look at each of the components. So if we cover up I, we have this 2 by 2 matrix left. So we're going to have 3, negative 2, 4, 2, I hat. You subtract the J hat component. So if we cover this up, I can't really see. We have 2, negative 2, 0, 2, J hat, and now the K component, which is going to be this square matrix. 2, 3, 0, 4, K hat. Now we take the determinant of each of these 2 by 2 matrices. So for example, this one would be 3 times 2 is 6, minus negative 2 times 4, which is negative 8, so we have 6, plus 8, which is 14. So this is going to be 14 I hat plus 4 J hat plus 8 K hat. So you can also write it in vector form, 14, 4, 8. So now we're going to get to answering the question of what is the area. So the area of a triangle, normally we'd use 1/2 base times height. If we're using the vectors, it's going to be 1/2 times the magnitude of our vectors, so PQ, crossed with PR. This finds the area of the parallelogram, and that's why we're dividing by 2, just like base times height is the area of the parallelogram, and we divide that by 2. So, magnitude of this cross product is going to be 1/2 square root of the sum of the squares. So we have 14 squared plus 4 squared plus 8 squared, which is going to be equal to 1/2 times 2 root 69, which is just the square root of 69. And that will be the area of the triangle.